Hello, my little physicists. I wanted to help you out with doing tricky projectile motion problems where the object lands at different heights. And we're going to do it using a quadratic method. So, this is a problem you've seen before. A ball is hit and it lands 7.5 meters above the point at which it was hit at. And we know the initial velocity and angle. So the first thing I need to do in order to fill in my givens chart is break up my initial velocity into x and y components. So my hypotenuse is 41 meters per second, and I'm going to use SOHCAHTOA to find v naught x and v naught y. So all of you should be great at doing that. And then I'm going to fill in my givens chart. I know my initial velocities, which I just found. I know my accelerations in both the x and y direction. And because I made 9.8 negative, you can tell that I've made down negative. Another thing that I know is I'm not sure of the y height to the peak of the ball's path, but I do know the y height to the end of the path, and that's a positive 7.5 meters. I started low and I ended up higher. Okay, so what we're going to do is use this formula right here that we're used to seeing, and what we know about this formula is it's actually referencing the change in y. So it can be written like this guy over here. So what they did is they wrote the y at the end of the path and the y naught, which is the height at the beginning of the path. So they just rewrote delta y. So we can fill in what we know into this formula, which is a quadratic because of this squared right here. So I know 1/2 g is equal to negative 4.9. I know my v naught y is equal to positive 20.5. And then my initial y height is 0. I'm starting at the 0 level. And then what happens is I end up landing positive 7.5 meters above that 0 level. Now, I can't solve a quadratic unless it's equal to 0. So what I'm going to do is move my 7.5 over to the right-hand side. And I did that here, and I have minus 7.5. So I'm going to take this full statement and graph it in my calculator. And when I graph that, I get this over here. So it's going to look like a parabola. It has a negative y-intercept. It rises above the x-axis and then falls. Okay, so we need to know, what do I care about? To find the time after the ball passes the vertex and lands 7.5 meters above my starting point, so right here, my starting point, I need to look at my biggest x-intercept. And the reason for that is that the ball rises, it passes 7.5 meters above my starting point, it keeps going to its peak, which is represented by the vertex, and then it falls back down to the 7.5 meter level. So I am interested in my biggest x-intercept. And when you're looking at your graphing calculator, to find the value of that x-intercept exactly, because I can't really tell from my graph up here, I need to use second trace 0. So you should be able to find that on your calculator. And it's going to ask you to mark your left and right bounds. And I showed you up here, you're just going to estimate, mark somewhere to the left of your x-intercept, somewhere to the right of your x-intercept. And then the last thing it asks you to do is make a guess. So you're going to move the cursor to as close as the x-intercept as possible. And when you do that, the calculator spits out this answer. Except it's giving you the answer in mathematical coordinate form. This is x and this is y. That does not mean anything in physics, so you have to tell me what that means. You cannot give me this answer. So what it's saying is the solution for x, the x-intercept, the root, the 0, is 3.78. Okay, and that means, since we're trying to solve for time, that the time it takes to rise up to the peak and then fall back down to 7.5 meters is 3.78 seconds. You would also be able to use the same method to find the first x-intercept, but that's not the one we were interested in. Okay, so if you're ever asked to find time on a projectile motion problem that ends at different levels, you can use a quadratic graphical method, and it should be pretty easy. Let me know if you'd have any questions.